Okay, so for this video, I'm going to show you how to look for problems with your printed circuit board, or PCB for short, and how to fix them. Before I begin this video, special shoutouts to Jason Brett, who designed this circuit board, which is for a 4x4 LED matrix. So the very first step is to begin and look at the actual traces and paths. So the traces are the individual lines, and the paths are the big circles and the little circles. Regardless of whether they're traces or paths, both the traces and the paths are designed to direct electrical current to where you want it. So one of the first things that you should be looking for are traces and paths that should not be connected, but unfortunately are, most likely due to a poor etching job. So as I visually inspect the circuit board, I can see that there is a little bit of copper that wasn't properly etched off, and as a result, it's connecting this trace with this one, and I know that that shouldn't be the case. So for this one, it's an easy fix. All you need is an X-Acto knife. So here's my X-Acto knife. Take your X-Acto knife out, and all you need to do is just scratch that trace off. And now you can sort of see these two traces are now completely independent of each other. And I've gotten rid of any unwanted bridges. Some are harder to detect by the naked eye. So for example, this one and this one, it's really hard to tell just by looking at it. So for inspecting these traces, or these paths rather, you're going to need to use a multimeter. So over here is my multimeter. This is where I get my reading. And these two things are called the leads. So I'm going to start by twisting it over to perform a continuity test. And what will essentially happen is this multimeter will start to beep if there is a path for the electrical current to flow. So for example, if I were to take this lead and put it onto this part of the table, and I were to take this lead and put it onto this part of the table, I'm hearing no beeping because there is no path for the electrical current to flow between this end of the lead to this one. Alternatively, if I were to put it against this X-Acto knife blade, I'm hearing a beep because there is a path for the electrical current to flow between the two leads. And since I'm hoping that these two paths over here are not electrically connected, what I'm hoping for is that I should hear no beep. So I'm going to take my first lead, put it here, and I'm going to put the second lead onto the other pad that I'm testing. And because I don't want them connected, I do not want to hear a beep. So since it's silent, I now know that these two paths are not electrically connected, which is a good thing in this case. The other type of problem that you should be looking for on your printed circuit board are traces and paths that should be connected but are not because the etchant accidentally ate away too much of the copper. Or drilling mistakes. So for example, I know for a fact that this trace here and this trace here needs to be fixed because they accidentally drilled in the wrong place. And then there is a potential problem over here because I wonder whether or not that this cut here actually disconnected these two traces, which should be connected. And I also wonder about this area over here because we cannot see them with our naked eye. Well, I mean, we can see this one with our naked eye. But if we want to know whether or not we need to fix these two, we're going to need our multimeter once again. So again, I've set my multimeter to the continuity test. And this time, because I want electrical current to flow beyond the traces, what I do want to hear is the beep. So in this case, I should hear, for example, I know that this point here and this point here should be connected, and as a result I can hear a beep. So now I'm going to test I'm going to start, and we'll start with this one. Since I hear no beep and I know that this should be connected, this part will need to be fixed. This one's good. This does not need to be fixed. And for this one's good as well. This one also won't need to be fixed. So in order to repair this broken trace over here, we're going to need to have the following tools handy. We're going to need a soldering iron that's plugged in and heated. With the soldering iron, we're also going to need some solder. We're going to need some flush cutters. And just look around your shop and grab a scrap electronic component. I'm choosing to use a resistor here. Now we're ready to begin our repair. So to fix the trace, you begin by taking your scrap electronic component. Here's my resistor. Get the two leads nice and straight. And gently lay one end of the lead onto a part of the trace. So I'm going to just put that over here. And so as you notice, the scrap resistor lead is now resting firmly onto a part of the copper trace. Get your soldering iron. Clean up the tip so that it's nice and shiny. Take some of the solder and carefully melt some solder onto the resistor. Let that cool off. I'm just going to rotate it. And make sure that solder is firmly onto the lead. Do be careful. The electronic components do get hot after a while. So to cool that off, I'm just going to blow on it. And what I have essentially done is I have made or secured one end of the lead to here. So what I'm doing is I'm using this lead or this wire to become the new trace, to replace this broken trace. So now what I'm going to do is I'm going to apply a little bit of solder here. As I'm putting the solder on, I'm being very careful not to make sure that I don't actually put solder onto the other traces that shouldn't be connected. I'm going to let that cool off for a little bit. Now I'm going to twist the resistor up. I take my flush cutters and I trim as close as I possibly can to my lead. And there we go. And the last step is to pull out the multimeter, set it back to the continuity testing, and test to see if my new wire or my new trace connects these 2 points. At this point, I should hear a beep. The fact that I'm hearing a beep means that now there is a path for the electrical current to flow through, which means I've done a good job of fixing this bridge. Before I begin to solder the actual components onto my board, I just want to double check and inspect a few things. Double check again that the pads and traces that you know are not supposed to be connected, double check that they are in fact not supposed to be connected. And also double check the traces and pads that you know are supposed to be connected, double check to make sure they are in fact connected. Once you have done your inspection, you are now ready to go and solder your components on. Thanks for watching and good luck with your own circuit board.